By March 1940, Britain faced a mathematics problem that would determine whether the nation starved or survived. Admiral Karl Dönitz's U-boats were sending 300,000 tons of merchant shipping to the Atlantic floor every month, and the Royal Navy possessed exactly 200 escort vessels to protect thousands of miles of convoy routes. Winston Churchill, newly appointed First Lord of the Admiralty, scribbled a desperate memo that spring: "We need ships, not tomorrow, not next year, now." The traditional answer sat gleaming in British shipyards: the destroyer. These sleek warships represented the pinnacle of naval engineering, bristling with 4.7-inch guns, torpedo tubes, and enough speed to run down any submarine on the surface. They were magnificent. They were also completely unaffordable. Each destroyer cost $900,000, roughly $45 million in today's money, and required 18 months of skilled labour to complete. Britain's shipyards could produce perhaps 30 per year at full capacity, whilst her merchant fleet was bleeding out in real time. The Admiralty needed a different equation entirely. In May 1940, as France collapsed and the U-boat threat intensified, naval architect William Reed presented a proposal that senior officers initially dismissed as absurd. His design wasn't even meant for war. Reed had spent the previous decade perfecting a commercial whaling ship called the Southern Pride class. Sturdy, simple vessels, built to chase whales through Antarctic storms. These ships used off-the-shelf components, commercial-grade steel, and construction techniques any coastal shipyard already understood. They were slow, uncomfortable, and utterly unsexy. They also cost $90,000 each and could be built in 8 months. That tenfold cost difference represented more than accounting. It meant the fundamental arithmetic of the Battle of the Atlantic could be rewritten. For the price of a single destroyer, Britain could deploy 10 corvettes. For the 18 months required to build 3 destroyers, shipyards could launch 20 corvettes. Reed's proposal transformed the question from "How do we build the perfect submarine hunter?" to "How do we blanket the Atlantic with enough hulls that U-boats can't avoid them?" Commander George Creasy, Director of Anti-Submarine Warfare, grasped the implications immediately. The Royal Navy didn't need floating fortresses, it needed presence. Every convoy required escorts, lots of them, positioned in overlapping screens that denied U-boats safe attack positions. Destroyers were exquisite surgical instruments, but the Atlantic demanded a blunt force solution. On 25th of July 1940, as the Battle of Britain raged overhead, the Admiralty placed orders for 58 corvettes designated the Flower class. They would be named after flowering plants: Gladiolus, Bluebell, Campanula, a deliberate nod to their humble, garden-variety nature. The decision sparked furious debate. Traditionalists argued Britain was abandoning naval excellence for quantity. These vessels could barely manage 16 knots, half a destroyer's speed. They carried a single 4-inch gun versus a destroyer's 4 main weapons. Their anti-submarine armament consisted of depth charges rolled off stern rails, not sophisticated ahead-throwing weapons. Yet none of that mattered when the alternative was empty ocean and undefended merchantmen. By September 1940, as monthly shipping losses approached 450,000 tons, the first corvette, HMS Gladiolus, completed trials and steamed toward the western approaches. She looked nothing like a warship. She would save Britain anyway. Dönitz had been refining his doctrine since 1936 when he first commanded Germany's rebuilt U-boat arm. Traditional submarine warfare treated each boat as a solitary hunter: stalk, strike, disappear. Dönitz recognized this wasted the submarine's greatest advantage: invisibility. Instead, he developed Rudeltaktik, wolf-pack tactics. A lead U-boat would shadow a convoy on the surface, reporting position whilst sister boats converged. When 6 or 8 submarines surrounded the target, they attacked simultaneously from multiple bearings, overwhelming escorts through sheer coordination. The mathematics were brutal. A single destroyer could chase down one surfaced U-boat, perhaps engage a second, but 6 U-boats attacking from 6 directions? The escort spent the entire engagement racing between threat axes, whilst merchantmen burned. On the night of 18th of October 1940, Convoy SC-7 learned this lesson in blood. 43 merchant ships sailed from Sydney, Nova Scotia, protected by just 2 escorts. 5 U-boats found them south of Iceland. By dawn, 21 ships had been torpedoed, the worst single convoy massacre of the war. The escorts never stood a chance. They couldn't be in 6 places simultaneously. Churchill understood the geometry perfectly. In his first major speech as Prime Minister on 19th of March 1940, he coined the phrase, quote, "Battle of the Atlantic," the only campaign he admitted genuinely frightened him throughout the war. Britain imported 55 million tons of supplies annually. Food, fuel, ammunition, raw materials for factories. Lose that lifeline, and military resistance became irrelevant. The nation would surrender or starve within months. Yet protecting that lifeline required escorts Britain didn't possess. The Royal Navy counted 200 escort vessels in September 1939. Dönitz commanded 57 U-boats, with production ramping toward 30 per month. Every tactical exchange favoured the attacker. The Corvette solution didn't beat wolf packs through superior capability, it beat them through ubiquity. Dönitz's tactics relied on escorts being outnumbered and outmaneuvered. What happened when convoys carried not 2 escorts, but 8, 10, 12? Suddenly the arithmetic inverted. A wolf pack forming around Convoy on WW2 in September 1941 encountered HMS Gladiolus, Bluebell, Campanella, Nasturtium, and 4 more corvettes forming a protective ring. When U-boats tried coordinating surface attacks, corvettes were everywhere, forcing submarines underwater where they lost speed and coordination. The pack scattered. This represented a philosophical revolution in naval warfare. For centuries, British doctrine emphasized individual ship superiority. Build better vessels than your opponent, then defeat them in single combat. The Corvette embraced opposite thinking. Build adequate vessels in overwhelming numbers, then win through saturation. It was profoundly un-British, almost industrial in its cold logic. Senior officers hated it. Admiral Dudley Pound called early corvettes scarcely fit for their task. He was right. Individually, they weren't. Collectively, they were unstoppable. Between October 1940 and March 1941, 30 corvettes entered service. Monthly merchant losses actually increased, the happy time for U-boat crews who sank vessels faster than Britain could replace them. But the trend line was shifting. Every new corvette narrowed the escort gap. By May 1941, 89 corvettes prowled the Atlantic, and average convoy escort strength had tripled. U-boats still found targets, but coordinating attacks grew exponentially harder. Dönitz's wolf packs discovered their prey now travelled with their own pack, slower, less elegant, but numerous enough that superiority no longer mattered. Presence did. The cheap fishing boats were hunting back. The blueprints Smith's Dock Company unrolled in August 1940 showed a vessel 205 feet long with a 33-foot beam, dimensions lifted almost directly from the Southern Pride whaling ships that had operated in Antarctic waters since 1936. Naval constructor William Reed hadn't designed a warship at all. He'd taken a proven commercial hull, removed the whale processing equipment, and bolted on military fittings. The Admiralty specification was deliberately primitive, reciprocating steam engines instead of modern turbines, riveted construction instead of welded, and a single-screw propeller. Every choice prioritized one criterion. Any shipyard in Britain must be able to build these vessels using existing skills and equipment. This proved transformative. Destroyer construction required specialized yards with heavy slipways, precision engineering workshops, and workforce teams trained in naval standards. Only 7 British yards possessed these capabilities. Corvettes needed none of it. Smith's Dock in Middlesbrough, Hall Russell in Aberdeen, Harland and Wolff in Belfast, even small commercial yards that normally built coastal freighters received contracts. The Flower-class design specified commercial-grade steel, plating 3/8 of an inch thick, standard merchant ship rivets, and components already in mass production for civilian purposes. Naval architect Reed later admitted he intentionally dumbed down the design, so a yard that built fishing trawlers could transition to corvettes within weeks. The engine choice illustrated this philosophy perfectly. Destroyers mounted Parsons geared turbines generating 40,000 shaft horsepower, spectacular machinery requiring specialist foundries and 9 months manufacturing time. Corvettes received triple expansion reciprocating engines producing 2,750 horsepower. These engines were Victorian technology, essentially scaled-up versions of mechanisms that powered railway locomotives. Britain manufactured them by the hundreds for merchant ships, tugboats, and industrial applications. When Corvette production accelerated in 1941, engine suppliers included companies that normally built colliery, winding gear, and factory steam plants. The engines were heavy, inefficient, and caused tremendous vibration. They were also sitting on warehouse shelves, ready for immediate installation. Construction speed reflected these compromises. At John Crown & Sons in Sunderland, Corvette hulls took shape in open-air berths using techniques unchanged since Victorian times. Riveters worked in teams of 4, 1 heating rivets, cherry red in portable forges, 2 driving them through pre-drilled holes, 1 with a pneumatic hammer flattening the opposite end. The process was noisy, labour-intensive, and desperately slow by modern standards. Yet Crown's workforce already knew these methods intimately from building merchant vessels. On 12th of November 1940 they laid HMS Campanilla's keel. By 3rd June 1941, just under 7 months, she completed sea trials and joined Western Approaches Command. Compare that to HMS Jervis, a J-class destroyer laid down at Hawthorne-Leslie in August 1937. Her construction required precision-matched turbine components manufactured in 3 separate factories, electrical systems custom-designed for naval specifications, and fire control equipment built to tolerances measured in thousandths of an inch. She commissioned in May 1939, 21 months later, representing 300,000 man-hours of highly skilled labour. Jervis was undeniably superior in every measurable category. She was also one ship. In the 21 months required to build Jervis, British yards completed 47 corvettes using the same total labour hours distributed across less skilled workers. Smith's Dock alone eventually built 42 Flower-class corvettes, launching 1 every 17 days at peak production. The yard employed riveters who'd spent careers building commercial vessels, welders borrowed from shipbreaking operations, and fitters trained in locomotive workshops. None possessed naval certification, none needed it. The Admiralty had consciously sacrificed perfection for volume, betting Britain's survival on whether quantity could substitute for quality. By December 1941, 151 corvettes were in commission. The Atlantic escort gap was closing not through technological breakthrough, but through industrial brute force applied to a deliberately simple design. The destroyer HMS Electra, commissioned in February 1939, represented everything the Royal Navy understood about modern warfare. Her steam turbines drove her to 36 knots, fast enough to overhaul any U-boat on the surface and deliver her crew safely away from retaliating aircraft. 8 4.7-inch guns provided overwhelming firepower against surface threats. Quintuple torpedo tubes allowed her to engage enemy capital ships if required. Her ASDIC sonar could detect submerged submarines at 100 yards, whilst ahead, throwing Hedgehog mortars let her attack without losing sonar contact. Electra cost $922,000 and consumed 18 months of labour from Hawthorne Leslie's most experienced craftsmen. She was magnificent, genuinely capable of dominating any tactical situation she encountered. On 27th of February 1942, Japanese destroyers sank Electra during the Battle of the Java Sea. Britain lost $922,000 and 18 months of irreplaceable construction capacity in approximately 7 minutes of combat. This wasn't unusual. HMS Glowworm, HMS Hardy, HMS Hostile, destroyers worth nearly $3 million combined, were gone by June 1940. The Royal Navy began the war with 184 destroyers. By December 1940, 35 had been sunk or damaged beyond repair. Each loss represented not just combat capability, but enormous sunk costs in time and money that couldn't be recovered. Corvettes reversed this equation brutally. HMS Gladiolus cost $90,000, 1/10 destroyer price. When U-568 torpedoed her on 16th of October 1941, Britain lost a ship, certainly, but not an irreplaceable asset. 7 weeks later, Smith's Dock launched HMS Heliotrope to replace her. The entire cycle, loss, replacement, commissioning, took less time than building a single destroyer. This economic resilience mattered enormously in attritional warfare. The Battle of the Atlantic would ultimately destroy 47 corvettes between 1940 and 1945. Replacing them cost $4.2 million total. Replacing 47 destroyers would have consumed $43 million and monopolised British shipyards for 3 solid years. The time factor cut even deeper than cost. In September 1940, when monthly merchant losses exceeded 450,000 tons, Britain needed escorts immediately deployed, not perfect ships eventually delivered. Camel Laird began HMS Opportune, a destroyer, in July 1940. She wouldn't commission until August 1942, 25 months later. During those same 25 months, British yards completed 127 corvettes. Every one of those hulls could escort convoys, hunt submarines, and deny Dönitz the empty ocean his wolf packs required. Opportune was undeniably superior to any corvette. She was also unavailable when Britain needed her most.